next exercise 6. Here star is the binary operation on the set of natural numbers defined by this equation. For two natural numbers a and b, a star b is their LCM, least common multiple. There are some parts. The first part asks us to find 5 star 7 and 20 star 16. So let's do this first. 5 star 7 of course is 35. That means the LCM of 5 and 7. And similarly the LCM of 20 and 16 is 80. There's nothing more to explain here. It's just elementary arithmetic. Part 2 asks if star is commutative. And the answer is yes. That's because if you take any two natural numbers a and b, then a star b is the LCM of a and b, which is also the LCM of b and a, which however is b star a. I mean the LCM does not really depend on the order in which you consider the numbers. That's why star is commutative. Part 3 asks if star is associative. And here also the answer is yes, but we need to prove this. This is not as easy as showing that star is commutative. So I am now going to need space. So before we erase these parts, let's see the other parts as well. Part 4 asks us to find an identity element for our operation star in n. And part 5 asks which elements of n are invertible for our operation star, which elements in n of course. Now before I start the proof that star is associative, let me introduce a notation that will make things easy for us to write. For any two positive integers x and y, we would use this symbol to indicate that y is divisible by x. For example, you can write 2 followed by this vertical bar followed by 4 because 4 is divisible by 2. We can express this more simply by saying that 2 divides 4, whereas you cannot write 2 followed by this bar and then 3 because 2 does not divide 3. So if we use this notation, we won't again have to write say x divides y. I mean we don't have to write those sentences. So we start the proof by taking three natural numbers a, b and c, not necessarily distinct of course. And let k be a star b star c and l be a star b star c. So these names k and l will further simplify things. Let's first see what k actually is. By definition, k is the LCM of a and b star c. LCM means least common multiple after all. That means k is a multiple of a as well as b star c, or in other words, a divides k and b star c also divides k. But from this relation, you further have these two relations that b and c also divide k. Why? Because b star c is the LCM of b and c, so it's the multiple of both b as well as c. So both of them divide b star c, which however divides k, because divisibility relation is transitive, so b and c both have to divide k. So now we see that a, b and c, all these integers divide k. Let's now focus on these two things, that a divides k and b divides k. Because of them, we find that a star b also divides k. How? K is a common multiple of a and b. That's what these two relations are saying, right? Whereas a star b is the least common multiple, and least common multiple divides any common multiple. This is a property of LCM. From there we are getting this. Similarly, from a star b dividing k and c dividing k, we have a star b star c dividing k, because this is the LCM of a star b and c. K is the common multiple of a star b and c, so their LCM would also divide k. However, this is just L, so we have found that L has to divide k. Similarly, one can prove that k also divides L. Whatever we did up to this, starting with k, could have also been done starting with L. So that way, you can prove this other relation as well. So L and K divide each other. And finally we note this, since L and K are both positive integers, because LCMs are by definition positive, that is why these two divisibility relations imply that L has to be equal to K. If you do not have this positivity and you have two integers, both of which divide each other, then in general you can say only this, that L is either plus K or minus K. But because both are positive now, you cannot have L equal to minus K. That's why this is the only option. But then this is equal to this, and that means associativity. Next, part 4. For any natural number A star 1 and 1 star A, same thing, LCM of 1 and A is equal to A. And of course 1 is also in N, so 1 is an identity for our operation star. Finally, part 5, where we have to find all the invertible elements in N under our operation star. So let A in N be invertible, that means it will have an inverse which will also be in N. Let its inverse be B. Then by definition of an element and its inverse, A star B should be that identity which is 1. But what does this mean? It means that the LCM of A and B is 1. So A has to divide 1, because 1 is a common multiple of A and B, means it's a multiple of A in particular, and B also divides 1. We don't really need this thing. We just need to see what A will be. Because A is positive, so A itself has to be 1. Had A been a general non-zero integer which divides 1, then from this divisibility relation you would have concluded that A is plus 1 or minus 1, but A cannot be minus 1. So A needs to be plus 1. That means 1 is possibly the only element in N which is invertible. But is it really invertible? Yes, because 1 star 1 is 1. 1 is invertible with 1 itself as its inverse. So that's the only invertible element. Let's see another one, number 7. Is star defined on this finite set, the set of first 5 positive integers, by this equation, a binary operation? That means the definition of the operation is same that we have here in the previous one. A star B is LCM of A and B, but the set is no longer the entire set of natural numbers, and we need to justify. And the answer of course is no, because if you take, for example, 3 and 5 from this set and perform the operation on them, then you get 15, the LCM of 3 and 5, which is not present in the set. So how can star be a binary operation?